All right, guys, let's finish up this conversation on the acid-base system. I feel like I've been talking about acid-base and pH since the beginning of this course. So we remember from Chapter 2, pH is a measure of hydrogen ions and OH ions, and these two things are inversely proportional to one another. So think of it like a seesaw, with hydrogen on one side and hydroxide on the other. If they're perfectly balanced, that gives us water. H plus OH equals H2O, which is water. And that gives us a pH of 7.0, so that's perfectly balanced. If we add more hydrogen, we tip the scale to that acidic side, and it lowers the pH. If we add more hydroxide, or another way of thinking it, if you take away hydrogen, it makes the solution more basic or alkaline, and that increases the pH. All right, so pH system should be clear. Good? Sweet. In blood, remember the pH is 7.35 to 7.45, and it has to be kept in that really narrow range. Otherwise, proteins don't get made correctly, metabolism gets stalled or delayed, blood clotting factors don't work. It's basically just really bad things happen. So how do you keep that range? We use what's called a buffer system. So a little bit more chemistry, and for those of you who've done high school chemistry, I'm hoping this is going to be pretty straightforward. All right. So a buffer system is two chemical equations that go forward and backward to balance each other out. So let's start with the first one. Carbonic acid, which is H2CO3, breaks down to H plus and HCO3 minus. The H plus we'll recognize as our hydrogen ion, and that's the stuff that makes things acidic. The HCO3 is called bicarbonate. It's the same stuff you'll see in baking soda. All right, so carbonic acid is made of equal parts H plus and bicarb. That weird little equal sign in the middle means that this equation can go both ways. So we can take hydrogen and bicarb and put it together to make carbonic acid, or we can split the carbonic acid apart and get hydrogen and bicarb. Cool? All right, so why do we even care? Well, let's say our pH is way too high, so we've got way too much hydrogen floating around. How can we fix it? If you've got too much hydrogen, add some bicarbonate, they'll mix together, become carbonic acid, but the hydrogen will be gone and that'll lower the pH. So let's do a backwards one. Let's say we don't have enough hydrogen. So the pH is really high or it's basic, and we need to make more. How can you do this? We can take away some of that bicarbonate, which means the carbonic acid that we have is going to need to split up to make more, and that'll increase our amount of hydrogen we have. All right, cool. Add and get rid of bicarbonate. But how do we do that? Well, our kidneys can actually excrete or reabsorb the bicarbonate as we need it. It gets excreted at that glomulus and then reabsorbed as it's needed at the PCT. So if we need more bicarbonate or less, we just ask our kidneys to make it or pee it out. There's another way you can get more hydrogen. We can add carbonic acid, and this is going to cause that carbonic acid to break apart and make more hydrogen. So let's figure out how we can add carbonic acid. All right, another chemical equation. Water plus CO2 equals H2CO3. So water plus carbon dioxide is carbonic acid. Great, cool. So now we have a way to make the carbonic acid in case we need to use it in that first equation. But where do we get the CO2 from? Well, that comes from cellular metabolism, and it's excreted by our respiratory system. Now, it's kind of tricky to make your cells metabolize faster. We don't really have a lot of control over that, but we can change how quick you can get rid of the CO2. If we hold our breath and stop exhaling, the amount of CO2 in our blood is going to increase until we exhale. By increasing the amount of CO2 in our blood, it can mix with water and then make more carbonic acid. If we exhale a lot, say we start hyperventilating, then we'll blow off the CO2, and that'll cause the carbonic acid levels to decrease. All right, so that's a lot of chemistry, and I know it's takes a minute to kind of get your head around it, but I've got a little tiny bit more. We're going to take these two formulas, and we're going to stick them together. So now we have a way to balance out our pH. So, like I said, I get it. This is a lot. It's kind of hard to get your head around. We're going to do some examples to see if we can help you guys apply this. So let me just summarize them really quick. If our pH is high, it means we don't have enough hydrogen. So we can do one of two things or both. We can get rid of the bicarbonate, by having our kidneys excrete it and pee it out, or we can hold on to more CO2 by slowing down our respiratory rate. If our pH is low, that means we have too much hydrogen, then our kidneys can reabsorb that bicarbonate and put it back into the blood, or we can start breathing faster and blow off CO2. So the way the kidneys affect pH is called the metabolic system, and the way the lungs affect it is called the respiratory system.